Now let's try to understand the symmetry between or the symmetry of velocities in a projectile motion. What are the paths that we are considering? Motion along AB and then to C. So motion along A to C through B. Then we have the corresponding motion downwards, which is motion along CA through B. And the body is in the same position B along the upward motion and the downward motion at two different times T1 and T2. We are trying to understand the velocities at T1 and T2. To express T1, what we'll do is from A to C, the total time taken is T, which is time taken to reach the apex point TA. The time taken from B to C, is delta T. If we consider time taken from A to B as T1, what is this T1 equal to? TA minus delta T. So T1 would be equal to TA minus delta T. Correspondingly, when the object is coming downwards, it will have delta T for some time, right? And it will cover the equal time interval downwards, which is, which will cover the same distance delta T. Now, delta T from A to C, it has covered the time TA. From C to B, it has covered the time delta T. So from A to B, it will be sum of time from A to C plus C to B. So T of AB will be equal to T of AC plus T of CB. What is T of AB? It is TA. What is T of CB? It is delta T. So we have two times TA minus delta T and TA plus delta T. Does that make sense? Okay. So we'll find out the velocities at TA minus delta T and TA plus delta T by the equation V is equal to U plus AT. What is V? The final velocity at T minus delta T, T plus delta T. U plus AT. U is the velocity with which is launched. A is minus G. So A into TA minus delta T is ATA minus A delta T. A is minus GTA plus G delta T. ATA plus A delta T. A is minus GTA minus G delta T. U plus minus delta T is U minus delta T or U minus GTA. U plus minus GTA is again U minus GTA. So the only difference what we have here is plus GT and minus GT. What is U minus GTA? See, for the complete motion along AC, what is V is equal to? V is equal to U plus AT. What is V? V is the velocity at C. What is U? Is the velocity at A. Plus what is A? A is minus G. What is T? T is the time of ascent. Why? Because it is the maximum position. At the maximum position, velocity at C is equal to 0. Why? Because it is momentarily at rest. Therefore, VC is equal to 0, which gives us minus VA is equal to minus GTA, or VA we assumed here as U. So U is equal to GTA. So what is U? U is GTA. If we plug in that value here, U is equal to GTA. U here is equal to GTA, right? So GTA minus GTA is equal to 0. GTA minus GTA here is equal to 0, which means we have V at TA minus delta T is equal to plus G delta T, and VTA plus delta T is equal to minus G delta T. What is the inference? The inference is VTA minus delta T is equal to minus VTA plus delta T. That is, velocities are of the same magnitude, but the opposite direction. Okay. Let us also look at the graph here. So symmetry in velocity means magnitudes are equal at corresponding times, but the directions flip. Minus flip. If it leaves our hand at 20 meter per second upwards, it will return to our hand at the same speed, same magnitude, 20 meter per second, but direction flipped, positive 20, it comes to our hand at negative 20. The speed is the same, and therefore energy is conserved, but the sign changes, which means the direction of motion is reversed. If we were to understand the graph here, so we have velocity in y-axis, time in x-axis, velocity plotted from negative 20 to positive 20. So at time 5 seconds and at time 2.5 seconds, we have the corresponding velocities as, okay, wait a second. Yeah, that'd be a better way of comparing, right? So at time is equal to 1.5 seconds, the velocity corresponds to plus 5. At 2.5 seconds, the velocity corresponds to negative 5. So this is what we mean by symmetry of velocity. Okay. So yes, so these are the things that are that I was mentioning about. Is the underlying concept behind this question. So could be a potential case of upcoming JEE Mains, right? Now, are we done? No, we are not. Why? Because we now will understand the symmetry of time, which is the foundation for symmetry of velocity and displacement. In fact, I should have taken you through time first and then velocity and displacement, but I just took you the other way around. I'm really sorry, because the reason why I did was I wanted you to think, why did I take that region as time of ascent, and then am I implying that it is equally half in both sides? Because I've been repeatedly telling this in throughout the solution, this particular question, that we are dividing this motion into two halves, the first half and the second half. But then what is the proof that these two motions are actually the half of each other? Right? That is what we see in the next part.